Alright, Crewton Ramone's House of Math. Fooling around with straight lines. Y equals mx plus b. Oops, let's put this down a little bit. Y equals mx plus b. We got a point and we got the slope, and now we're figuring out, if that's 3, 2, well that's 4, but I asked them, how do I get mx plus b out of this? And then we found out that it's rather important to do this, right? Because this is 1, 2. This is 1, 2. So this one has to be 1, 2, right? And see, my line is off 2, right? And then 1, 2. Right? I mean, each time. So it's that slope, and like I said last time, this is plus or minus. This is always plus. Right? So if I can keep that in mind. But if I want to go from here, then I got to go down 2 and over 1 that way. Right? And then down 2 and over 1 that way. So what's my form going to be? My y-intercept?
Y equals 2x minus 4.
Okay, or yx equals 2x plus negative 4. And there you go. Okay. Now, last week, and here, I just want to do this one fast. See, because we got it, right? Because this is your x and this is your y, right? So I can either subtract 2 and minus 1, right? Or I can add 2 and minus 1. That's how I got those points. And I can do it over and over again to get to here. Or I can just take these two and figure out, well, let's see here. If I know that, well, let's think about it. If I know that x is 3, right, and y is 2, well, let's see here. If I put 3 in there, right, because it tells me x is 3, well, what's 2 times 3?
6.
Okay, but it's not 6, it's 2. So what do I have to do? I got a minus 4.
Yep.
Make sense? Right? So you see why I don't have to do it over and over again? I can use mathematics to figure out my, formula? Okay.
So
because once I know, because like I said, once I know, I'm done. Okay. Go to my website, and I have stories. I'll try to find it for you between now and the next time, but you should be able to go to my website, and it's either in module 3 or 4. We're going to go to a donut factory with Muy Mukau! So just look up Crewton Ramone Donut Factory. Problem is, it's probably behind one of my paywalls, so you might not be able to find it. Did somebody mention Muy Mukau? But this is a fun way of learning a little bit more about y equals mx plus b, etc. I don't want to go to a donut factory with you because we got other stuff to do. But watch that on your own time. Now, here's the thing. And here's another thing you got to know about, or I guarantee you they're gonna throw your way. Is you're gonna have inequalities, where I have something like, instead of y equals 2x, what did we just do? 2x minus 4 plus negative 4. They have y is greater than that, right? Or y is less than that. Now here's the thing. A lot of time kids get confused with this and this, right?
I mean, it's essentially like solving with an equal sign in the middle, except when you multiply or divide, you just have to flip the sign.
Okay. So multiply or divide by what? Negative 1 is where that comes from. Not just any time. But alright. But okay, so just so you keep a handle on it, here's my... What do you call it?
Your 0?
There's my 0. No, wait. Here's my line, right?
Your midpoint?
Yeah. Okay. Okay. Sure. But the line itself. So that's my line right there. And let's say this is negative 5, and this is positive 5. Okay. So negative 5 is where compared to 5? Is it over there or is it over there compared to 5? Yeah, that's it. Done. -5 is less than 5, right? Right there. That's what it is. Right? Okay. So let's change it around. What about 5? Where's 5 compared to -5? Is it over there or over there? It's over there. There you go. Because it's greater than. Oh look, there it is. Right? That's where that comes from. My number line. Right? I put my numbers on a line and I arranged them left to right. I made positive over there arbitrarily, and I made negative over here. Right? And then same thing up here. This is my positive over here, and this is my negative down there. Right? Okay. So now we should have no problem with that much information. So then that number line is just like that, right? I just tilted it that way. But you guys remember, positive, up, right? Or that way. Negative that, or that way. Right? Alright, we're happy. So now, let's just, like I said, there's just a quick review, right? Just to make sure we get it. Let's say I'm going to solve. I'm going to solve for two of them. I have, sure, why not? Let's go with y equals, get your piece of graph paper out. And you can use the same one. We'll just go, the same piece of graph paper, don't use up more. Y equals 3x plus 2, just for fun. And y equals, -1/3 x. Oh, it's the negative reciprocal. Plus, what do I want? To make it a cool looking graph. Oh, let's make it plus -2. Graph that. Oh, wait. That's not fun. We'll make this is greater than, and we'll make this is less than. Now we're going to have a fun looking graph. Now you know that if I have this, that it's a dotted line, right? It's not a solid line. Because it's everything right up to, but not including, right? Same thing here. Alright. Now if I put an equal sign in there, then I can make it a solid line. And a solid line.
Yep.
Right? Just remember that. If there's no equal sign, it's a dotted line.
Yep.
Right? Okay.
So, I mean, if I were to graph this, I would just go, so I'd start off with the intercept, so 0. And
can I find, I had some graph paper. Here's my graph paper. Alright. So yeah, I'm gonna, here I'll show you how I do it. And just because it's how I do it doesn't mean it's how it is. This graph paper is too small for my poor vision. Alright, so let's see here. I'm going to start off at +2. And then what's it say? It says up 3 over 1. Up 3 over 1. Up 3 over, I got more than enough already. Down 3 over 1. Alright, see how I got my dots there, right?
Yep.
Okay, and then I can do down 3 over 1 again. Down 3 over 1 again. Alright, look at that line. Easy. Okay, put an arrow on it, because they go forever in every direction. Okay, now here's the issue. What side do I shade on? Well, it tells me, shade on that side of the line. Right? Over there. So it's everything over here. Everything over here. Right? Oh look, I just did that one. Now, I do this one, and it says, you see, I told you that rise over run thing? It's a lie! Negative slope, right?
Yep.
So I have negative slope, that means I go down 1 over 3. Alright, so where do I start though? I start at -2. So I'm going to start down here. See, like I said, I'm going to make this a cool looking graph. Start at -2, and then I go, what do I do? Well,
You go
down 1, right? Over 3. Okay. Oh, look at that. And then I go this way, up 1, up 3, oh, the other way. And then I go down, up. And I go this. Oops. Is that 3? 1, 2, 3. So like I said, this graph paper is too small for me. 1, 2, 3. There you go. Getting old, man. All right, so then put a line through that. And you gotta label these guys, right? Label your axes and label the things. I'm being lazy. Like I said, label your lines.
Yes.
Okay. And then what does it say? It says, well, I gotta graph everything on this side, right? It says up. So everything, not over here, but everything over there. So then my solution set, all the numbers in here, right? Because it's that way. Okay, so this is my solution set. Now, I have these equal, so these lines are solid. If I took this off, then this is just, these are dotted lines. Because it's everything right up to that line, but not including that line. So this is a dotted line. And then I missed that one. There you go. Gotta hit the line. Gotta hit the dots. There you go.
So essentially, what we're doing is we're just starting with the intercept. So 0, 2 for the first one, and 0, -2 for the second one.
Right.
And then we use the slope to create a line.
There you go.
And
Simple.
then what did you say was the solution set?
Everything in here.
Gotcha.
All of that. Right?
Yeah. So.
Because I know, and I could change it if I changed it to be. So now here's the thing. But I did this on purpose because what we have here are perpendicular lines, right? And this is I make a perpendicular line with a negative, right? Okay. So let's see here. If I wanted to change this and I made this one negative also, then what happens to my solution set? Is it over here anymore? Well, no. Now it's down there, right? It would be here in that one, right? Because when I do the negative, like I said, if I want to make a perpendicular line, negative inverse, right, of whatever this is, right? That was 2. This would be 1/2, etc. If this was a third, and I wanted a perpendicular line, the negative inverse would be +3, right? Okay. So now, let's say I want to. Oh, well, I'll tell you what. Let's do this. Let's leave this like this, and then change this one. Now, where am I? On this. Well, you tell me. Oh, okay.
So if you flip the top one.
So now it's going to be y is greater than that, right?
Oh wait, is it?
So now everything's going to be on that side of the line, right? For this one. But everything's still going to be below the line on this one. So now look, we just walked over here.
Okay.
Right? No, you don't look good. You don't look happy. All right, hold on a second here. I can tell. See, that's why. Wait, hold on. I'm gonna take a second and erase this.
Is it just a matter of, okay, let's see. Okay.
Alright, so now, if I do this, I have this line right here. This is y equals, at the +2. But it's everything on this side, right? And then on this one, everything down here. So I went, oops, for that one too.
So
I now wind up over here.
Recording, so like, it's like, okay, so each line, let's imagine the equal signs are arrows. And then based off of how the equal signs are aligned in the equation, you just base it off of that, and then you get a space, and that's what the solution set is?
Yes. Where they overlap, right?
Yeah.
Okay, and they'll be bounded by the lines themselves.
Yeah.
And then if I want to go up here, what do I have to do? Well, then I have to change this one. Correct? So if I do that, now I'm over here. Because I'm over there on this one, and I'm over there on this one.
Yep.
Got it? Oh, that used to make me crazy. I remember, I think it was 7th or 8th grade, used to make me nuts. Because I could never keep it right in my head. But once you figure it, see, because you know why? No one ever bothered to explain to me that on the number line, that is that, and that is that. Right? Yeah. That's where these things come from. So, oh, everything over there. Right? And then I just did the same thing. Now I say everything on this one over there. So even though this line is pretty shallow, it's still there, not this side, right?
Mm-hmm.
Okay. And you know what I should be using? I should be using a Sharpie, but I don't have one handy to draw these out. Once first in pencil and then in Sharpie, right?
Wait, so okay.
Because you want to do.
Function is greater than y.
Mm-hmm.
Does that mean you would use the up?
Yes.
The up or to the, okay.
Y. Well, okay. Wait a minute. Here y is greater than our function.
Okay.
Right?
I'm just trying to for the first one we did, it was y is less than 3x plus 2, so I'm just trying to figure out.
All right, there you go. I know. I understand. Okay, so if I do this, right, y is less than that. Well, I'm on this side of that line. Right? Because it tells me, the arrow tells me that it's everything over here. Y is everything over here.
Okay.
Right? Now this one, oops, and now this one's messed up. And if I do that, now it tells me on this one that y is everything over there.
Mm-hmm.
On that side of that line. Hold on a second. Well, look, I do have a Sharpie. Let's make this so that it can be seen on the camera because it's awfully light even with a pencil, even with a number 2 pencil. Alright, so that becomes easy to see, doesn't it?
Wait, so for this, wouldn't it... so it's not... So, okay, y is...
And then, what's the solution to this? If I didn't want... what's my solution set? In other words, where do the lines cross?
Yeah.
Yeah.
So for this problem, if you're saying, y is going this way.
There, how's that?
Y is going, negative or less than.
Is that better? Easy to see? Easier to see?
So that's the solution set?
It depends on... Okay, so on this one... Hold on, now I gotta erase. So I don't have it here. Do you see I've basically made quadrants now?
Mm-hmm.
Alright, let me draw a line here. Oops. I'm just putting some... This one thing right here, I think it raised... I had a student, this little girl was great. I think I raised her score 120 points on the SAT just by going over straight lines.
Oh, wow.
Yeah. Okay, so do you see that I did 1, 2, 3, 4 quadrants basically here now?
Yes.
Right? Okay, so now, when I have this and this, which quadrant am I in? Well, on this line, I'm on this side, right?
Mm-hmm.
Tells me that side. On this one, it tells me that side.
Which line are you using? So are you using the line?
What do you mean, which line? You better know which line is which.
Okay.
That line is this line, right?
Yes.
And this line is that line.
So if y is less than, then you would want to go.
So I want this one. This one tells me that at the moment when I have this one pointing that way, it's everything on this side, right?
Okay.
Now, when I have this one pointing that way, it's everything on that side. So where it overlaps is right here. Right there.
Okay.
Right?
Yes.
All right. Now you tell me what I want to get over here. I want my solution set to be over here. What do I have to do to these?
What?
What? I said I want my solution set to be over here.
Okay,
So what do I have to do to these to make my solution set wind up over here?
Okay, so this. But can't you just flip the bottom one?
If I flip the bottom one, all right. See, and look, here's the thing. I was just going over this with my boy. Are you wrong? No, you're getting more information. Let's see what happens when we flip the bottom one. Well, if I flip the bottom one, now it's this one is everything over here, and this one is everything over here. So you're exactly opposite where I want to be.
Oh. Well, if I'm opposite.
So now you know it must be what?
Yeah. It must be
This one needs to be greater than also, right?
Yeah.
Because I want to be above the line, not below it. Yeah. And then this one needs to flip the other way. Because now I want to be quote unquote below the line. Right? Yeah. Because I want to be on everything that side of it. Mm-hmm. Okay, so now I'm over here.
Yep.
Got it? Alright, let's try again. What if I want to be down here?
Okay, so if I want to be down there. Would the first function be less than and the second function be greater than?
Let's see. The first function would be less than, greater than?
No, because then that's wait, okay.
I think that's right, right?
Greater.
Okay, and then over here, what does this need to be?
That needs to be less than.
There you go. Because now I am on this one, I'm everything over here, which would be this side of the line, right? And then I'm everything under here. Oh, yep, there I am in that quadrant. Got it. All right, no problem. All right, now last thing. What's that point right there? Where do they intersect? Where do these two lines cross?
Well, this is probably going to be.
So, how do I do it? First off,
how
do I find this point right there? Well, what do I need to do? What I'm saying is, I want to know when these two are equal. Well, there's one point where those two are equal, right?
Uh-huh.
So how do I find that point? Well, here's what I do. I set them equal to each other.
So you just mean like 3x plus 2
is the same thing as negative 1/3 is x plus negative 1/3 x plus negative 2, right? Mm-hmm. And solve.
Okay.
Right? Just set them equal to each other. I'll give you a second. So what's our first thing? Let's do it. 3x plus 2 is the same thing as negative 1/3 x minus 2.
Yes. I feel like I'm going to end up in a situation where I just have x and then is equal to 0. Or something like that.
Well, let's see here. I don't think so because...
Well, actually, let me see.
Because what am I doing? What am I going to get when I solve this? Well, you'll see in a second. But what's the first thing to do? Well, the first thing I'm going to do is hero 0.
What?
The first thing I'm going to do is hero 0. Hero 0! Hero 0! Get rid of that. Get rid of that. Now I'm down to 3x is the same thing as 1/3 x. Oops, this is negative 1/3 x. Don't leave that off. That's rather important, right? And then this is going to be minus 4, right?
No.
And then what?
Wait. You can, well, you could get rid of the fraction.
Hero 0 again!
Oh, okay.
Right?
Mm-hmm.
So what am I going to do? I'm going to subtract, or excuse me, add 1/3 of an x. And I'm going to add 1/3 of an x. What is that? That's 0. See, I'm making zeros, man.
Mm-hmm.
Right? 0 is your hero. Right? And when it's no fun, get back to 1. Alright, so now I've got this. And now I'm going to write the thing up here because now I'm going to have 3 and 1/3 x is the same thing as negative 4. Oops, is the same thing as negative 4. What a pain in the butt that is. Right?
Yep.
So what's 1x?
1x is equal to negative 4 over 3 and 1/3 x.
Oh my god. There's multiple ways to do this. I could multiply and get rid of that. Right? But I mean, what is that any fun? Get back to 1. So here what I have. What do I actually have here? I have 3 over, can you convert that into a improper fraction instead?
10. Okay.
10 over 3, right? Correct?
Mm-hmm.
Well, can I just multiply both sides by 3 over 10?
Yep.
Now that's 1, right? Like, no fun, get back to 1. And now what do I have? I have, this is getting ugly, but where I got room? Yes, I have room over here. I have negative 12 over what?
10.
10, which is the same thing as 6 over 5.
Yep.
So, let's do that. So, x is going to be, I'm just reducing, 6 over 5, and that's the same as 1 and 1/5, right? And you can look at that and see that, yeah, that it doesn't come out nice and even, but you're a big boy, you can handle it, right? But okay, so now I know if x is, we'll just leave it that way, if x is 6/5, what's y?
Y.
I just solved for my x. I figured out that x is, negative 6/5. That's hugely important to have that negative sign in there, right? Because it's below the x, right? Okay, then what? Then just put negative 6/5 back into either one of these, and it'll tell you what your y is.
Oh, okay.
Right? Mm-hmm. Isn't that what you're doing here? Because here's what we're doing when you get right down there. Here's calculus. Well, actually, just for fun, you give me a definition of calculus, being that you're studying it. Or actually, what are you in? You're in pre-calculus. So,
yeah.
What's your definition for calculus? I'm going to earn my money twice again today.
Well, I mean, I don't know. I mean, it's just a lot of...
What do you study? You see, that's what I mean. What are you studying? I don't know. You're going to study it for a year. I don't know. Right? And this is the thing. I have plenty of college students and even professors. They're teaching the calculus. What's calculus? And they give you some crazy convoluted long paragraph of nonsense to try to make it sound like they know what the hell they're talking about. Calculus. Right? One and several variables. Right here we're at 2 variables. We're not even at 3 variables yet, x, y, and z. So we're just at 2 variables. All right. And what we're studying is how, well, watch this. Did you see it? Oh, did you see it? Oh, okay. There's calculus right there. We need calculus to describe that. It goes up, it comes to a point, a limit, and then it comes back down again. There's a moment in time where it's not going up and it's not going down. I used to love riding swings because of that. Right, that 1 minute when you're, that one instant where you, and you're not going up and you're not going down, you're floating, and then you come back down again, right?
Yep.
Okay. That's how one variable affects the other variable. If x is this, what's y? That's calculus. We're studying how one thing affects another thing. That's it.
Yep.
Right? How X affects Y, how Y affects X. That's what you're studying. Okay. Now, and then we can do all kinds of fun stuff with integration and differentiation and so forth, but even that, what are we going to be doing with that? Well, again, we're going to be back to concept number 3, rectangles, because if I want to find, and we're talking in very general terms right now. Oh wait, let's finish this problem before I wax philosophical on other stuff. But the idea is, what I was going to say is, if I have a curve like that, well, that curve's it's hard to count that curve.
Mm-hmm.
So you know what we do? We cut it up into rectangles. Oh, rectangles are easy to count. Problem is, I got these little spaces. So I got to make these rectangles infinitesimally small, so those spaces are infinitesimally small, so that my rectangles approximate that curve. And then I add them all up.
Yep.
Done. And then I can find the area under there.
Mm-hmm.
Right? Okay, and because I got to bound it, right? If I want to know, I got to know where I'm at. And usually I'll take the whole curve, and then I got to know what this is, etc. Anyway, and I got to be able to describe that line using my mathematics, my calculus, right? That's generally going to be a quadratic function, or it can be a cubic function, whatever. Depends on, well, that's not going to be a cube, but the right. And we can describe those curves, and then we describe the area underneath and the bound and so forth, and then we can start figuring out what the area is. That takes calculus. Anyway, all right, so that's what you're going to study soon. But right now, we're just studying several variables, right? 2 variables, how this one affects that one. So if this one is 6/5, what's the y going to be at 6/5? So we got 1 point, right? I figured out where the things cross here after doing all my work. I'll get rid of that.
Wait, so
as soon as I erase it, you go, oh wait, you scared me.
No. You get -6/5. Plug it as the x.
Yes, because that's what x is. Didn't we just solve for x?
Yeah.
All right. So now I know that x is, or excuse me, y is going to be the same thing as 3 times -6/5 plus 2. So that tells me what my y is going to be. Well, what's my y going to be?
-18/5 minus 2. -28/5, which is negative.
Wait. How did you get? But I like -18/5. Oh, I see what you did. You just, oh, look at you, how fast you are. Oh, okay, I get it. You just made common denominators and add them together. I see. Because that's just the same thing as adding 10 over 5, right?
Yep.
Okay, so 28/5. I like it. Done. All right, and you could do, well, if we have -6/5, and then we could make this -28/5, right? There it is. There's my solution set.
There you go.
I like it. Right, and if I wanted to get all nuts, and you get a crazy teacher that says you got to put them into, because he doesn't like the improper fractions, or she doesn't like the improper fractions, well, fine. Then it's just -1 and 1/5, and that's what it looks like to me. And
then -5 and 3/5.
And then -5. Oops, -5 and 3/5. Exactly. Bam. Look at you. He's all doing the happy dance. Good stuff. All right, I like it. Right there, it is.
Yep.
Okay. Easy peasy. Exactly. It should all be easy peasy. All it was because it's fractions and kids hate fractions. It was just a little bit more work. Right? And I gave you one like that very, very much on purpose, so that we could stretch that brain of yours. Right? All right. Done. So now, look, we know everything about this. If I know these lines. I know where they cross. I know where they cross the x-axis. I know everything about this thing, right? All right. We're good. And we did that in, oh my God, 50 minutes went by? What happened? We've been here a minute. I thought we were here for like 5 minutes. Holy cow! All right, well, shoot. That's what I mean. It takes a while to go through these concepts. All right, so for sure, you want to go to my website. You got the passwords. I will try to find that. Get to that donut factory. Get to that donut factory problems and just watch a couple of those. Oh, it's also for sure, it's in Module 1 in Functions and Relationships. Go to that Series A manual. It has just the very basics there, but I mean, like I said, once you understand the concept, you're good. So you'll have a functions and relationship manual there, and you'll see, and you'll have several problems. Because like you'll have the water tank problem. That's the classic problem. How long does it take the water tank to fill up? Those kind of problems like that, right?
Yeah.
Okay.
So I have a couple of things that we can go over next time.
Yes.
Like finding minimum and maximum, finding lines that. Well, I think it's like.
Okay. Wait. Hold on a second there. I'll take some notes so I can prepare some lessons. So you want to do min-max, which is that's absolutely, that's important to know.
Making functions of lines that are parallel and perpendicular to each other. I think.
All right, so we just did perpendicular.
Yeah.
Right, and the way I find perpendicular is just inverse, right? Negative inverse.
Mm-hmm.
All right. Ooh, how do I find parallel? Okay, well, when I want to do parallel, the slopes have to be the same.
Oh, okay.
But then this is going to have to change, right?
Yeah.
Your y-intercepts. Does that make sense?
Oh. So
do me a favor, while we're at it, and while we only have moments left. Well, do you have to leave right at the top of the hour?
Yeah, I have to get ready and.
I tell you every time. I make time, and then you want extra time. All right, fine. Anyway, so we at least both of us, our schedules are nuts. We're meeting at 7 a.m. to try and make this thing work out. But all right, so do me a favor then, and give me a parallel line to 3x plus 2.
So is it literally just like I can keep the slope the same?
Exactly.
3x. So the slope is negative 3x, and then.
The slope is positive 3x. The slope is positive 3x. Dude, if you're gonna make a parallel line, you can't make that negative. Uh-oh, you just froze. Boo! Right at the end of class. Well, at least we got most of the class. All right, you're back. Okay, there you go. Okay, so I can't make that negative. What do I change? The only thing I gotta change is this, right?
Yeah, so it's just anything that is negative 2.
Dude, if I want a parallel line to this, I could literally just, let's see, I could go down 1, and I could be at, instead of positive 2, I could be at positive 1, and have the slope the same. That line will be the same, right next to it. If I want to be further away, I could make my slope, thing negative 5 over here. Oh, wait, that's way more than 5. 1, 2, 3, 4, 5, 6, 7. Negative 7 over here, and then I have a line going like this. Parallel. Right?
Yeah.
Dude, if I change this slope at all, I'm not going to be parallel. It's going to wind up running into it.
So as long as it has the same slope and different intercept, then we're in business.
And see, exactly. And as long as we're staying over here in Cartesian coordinates, we're happy, right? Because there's other geometry we can do in spherical geometry. Parallel lines are going to intersect eventually. Because we're in spherical geometry, and on a sphere, those lines are going to eventually, right? But we're here on the imaginary Cartesian coordinate plane, right? And that was René Descartes, supposedly, right? Where he figured out where if he was, the story goes, this story may or may not be true. Many stories in mathematics are just like legends, right? They're there to illustrate the point. They may or may not be true. But René Descartes was a crappy soldier, and he got captured. But he was part of the aristocracy, so they held him as a prisoner so that until they could work out the exchange. Because what they used to do is they'd capture the wealthy guys, not kill them, and then they'd hold them for ransom and get the family to pay them some gold to get the guy back, right? Okay, so that's what they were doing. And so while he was sitting in prison, laying on his back with nothing to do in a prison cell, he was supposedly looking at the ceiling, and there was a fly walking along on the ceiling. And he thought, because he had this kind of mind, he's a philosopher and a mathematician, that, well, if I know the two sides of the wall, and I can say where the fly is relative to the two sides of the wall, and that eventually became x and the y. Right? Mm-hmm. So if the fly is over here, I can describe the fly as being over 3 and up 5, right? And there you go. There are that's why we call them Cartesian coordinates from Rene Descartes. Mm-hmm. Got to study the men that do it. Okay, and then, or that gave us the mathematics, because they weren't just doing stuff to, torture children. They were trying to solve problems and explain things and describe things using mathematics instead of words, right? Okay, let's see here. So we got that. We got parallel lines. We got figured out that we can make perpendicular lines by just doing negative inverses. What else did we need? We figured out that we can solve and figure out where the lines cross just by setting them equal to each other. And we figured out that those symbols, these guys, they come from the end of our number lines. Exactly. There it is. There you have it. That's exactly what it is. It's not a joke. Right? Yep. You'd be amazed. There's no secret to this. And yet they somehow make it like with alligators eating stuff and Pac-Man. And no, it's just the end of the number lines. Okay. What else did you want to do? Okay, so you were doing min-max. What else did you want to do?
And then functions with, I think multiplicities, degrees.
Oh, and here's another thing, and something I want you to know before I come back. You figure this out. Domain and range. What is that? What the heck are they talking about when they talk about domain and range?
Isn't it just where the denominator is
Oh man, look at you trying to make it hard. All right, so go ahead. Give me a definition. But I want domain and range.
It's just where it's defined.
I'll give you a hint. One is x and one is y.
Domain is and range is y.
Okay, there you go. So domain is x, range is y. Why you gotta make it complicated? So in other words, we want to know, right? So domain is which way again? X and Y, right? Okay, so lefty righty, right? Mm-hmm. Like I said, just for little kids, or you're explaining this to your little sister or something. And range is uppy downy. There you go. Wow, look at that. My eraser took off. All right, I launched my eraser. All right. Okay, so we'll cover that, domain and range. That's pretty easy. And what did you say? Multiplicity?
Yeah.
Okay.
I think that was it, yeah. Did I say finding zeros?
That's always good.
Oh, yeah.
Finding zeros, finding roots of quadratic functions?
Mm-hmm.
That's easy. That's just factoring those babies. And then if not, quadratic equation, right?
Mm-hmm.
Okay, but yeah, let's just go over it so we know it, supposedly, right? But like I said, one problem. We literally did like one problem. Right? And then our time was up. I think I talked too much or something. Anyway, and then, yeah, if you think of anything else, email it to me.
Will do.
And then, like I said, Module 1, Functions and Relationships, and then in Module 3 and 4, you'll have examples of me working with kids, showing them how the donut factories work. Right?
Mm-hmm.
And that's just, finding, well, all that's going to be is like, say, oh, I shouldn't have erased that. But what it should have been is finding, I have a set of ordered pairs. Like, say, I give you, see, and this is where I say I have, like, say, 3, x is 3, 2. What do I got there? Well, actually, it doesn't matter. And then the other one is, like, say, well, let's make this easier, actually. Think of something over here. When x is 3, y is 5, and when x is... Oh, sorry, that's not right. When x is 3, y is 11, and when x is, we'll say 7, y is 22. Ooh.
Mm-hmm.
All right, 23. Yeah, okay. Give me, with that much information, now you have to give me y equals mx plus b. Don't be afraid. But I mean, what? I just gave you 2 points. Now you got to give me the line.
Well,
The expression on your face was awesome, actually. I wish I did take a picture of that. But anyway, don't. That's what I mean. Just go over there and you'll see it's super easy. Right?
Yeah.
But the idea is, if I give you the points, you should be able to give me the line. And let me make this look more like an M instead of an N. M. There you go. And what do we do? Let's do it real quick. I know you got to go, and we're past time, but let's just be fast. How do I do this? I'm going to give you the full-on synopsis right now, and then you're going to go back and look at the long way of going about it. Right?
Okay.
But, because, we can talk about express one number in terms of another number and so forth, right? But what's the easiest thing to do? Well, don't you know this very simple formula? You told it to me. dy dx. That gives me my slope, right? Mm-hmm. All right, so what's the difference in y's?
The difference in y's is 12.
All right, I like it. What's the difference in x's?
4.
All right, we're happy. Now, what's my slope?
It is 4.
Wait a minute, what's my slope? Dude, all you gotta do is reduce.
All right, 3.
There you go. So now I know my m is 3. Just figured out m is 3. And m is the same thing as 12 over 4, right? But that's the same thing as 3. Well, now, if my m is 3, that says 3 times 3 is 9, but it's not 9, right? So, because look, I just did y equals, I know it's 3x now. So what's 3 times 3?
3 times 3 is 9.
But it's not 9. It says 11. So what do I have to add?
Plus 2.
There you go. Done. And just to make sure, what's 3 times 7?
21.
But it's not 21. It's 23. So I have to add 2. Done.
Yep. Wow.
See, never panic. It's always easy. I'm telling you. It's just the way that they showed it to you. Do this formula, do this, and it start right. Oh no, I don't remember what to do. Okay, well now you know what to do.
What they have you do is, they get that, and you do y minus y1.
There you go, right?
X minus x1.
That's what you just did. That's what you just did.
Yeah.
Right?
Yeah.
But instead of me going y1, y2, and so what's the difference? That's what you're doing. That was, you took y2, took away y1, got that, and then you took y2, took away y1, got that, then you did division, got that. Now I know my slope, right?
Mm-hmm.
Okay, but instead of following formula, like I said, you need to know what to do.
Yep.
Right? Okay, and what you do is you dy dx.
Mm-hmm.
And then figure out, well, right? And see, and if I change the number, see, and I have little kids that after you do a few of these, after they get it, and bam, they do it. So this is the end of the lesson, right? You didn't do so. I want you to see the beginning of the lesson.
Yep.
Okay, that's on my website. Okay, we're out of time. Unbelievable. That went by really quick. Holy cow. All right, I will email me for when the next time we can get together.
Yeah, so honestly, so I sent you my schedule.
Okay, well, hold on a second. Crewton Ramone's house of math.com for more.